Hello everybody. My name is Antoine Lager, and I will today speak about it's a webinar that is titled Tecplot in a nutshell. It's to give you an overview of Tecplot novelties and what has been implemented within the software in 2015. Today's summary. So I will briefly present Genias graphics, so for you to know who we are and basically what we do. I will then speak about general simulation and the general visualization for simulation data in its very large sense. I will speak on the latest Tecplot release that are 360EX and Tecplot Chorus 2015 R2, and that have new technologies and ways to visualize and handle big data sets. I will also speak of interest about plotting and comparing experimental data. And we will end up with a test case about numerous dataset management and visualization of parametric or optimization studies. So basically, every time you have a huge number of files to post-process and visualize. So Genias graphics. So we are basically providing solution to visualize and analyze scientific data. We are a Tecplot exclusive distributor within Europe, and we have approximately 1,300 organizations that are using Tecplot in Europe. We have more than 20 years of experience in doing so, and we are based in Regensburg in Germany, which is here in the southeast, between Munich and Nuremberg. We are doing also some training, some consulting, as well as some software development. And our largest customers are mainly based from the aerospace domain, such as Airbus, Dassault Aviation, the DLR, MBDA, but also Marine, MTU, and so on. So regarding data visualization, so Tecplot 360EX is a tool that handles scientific data in its most general sense, and for example, it loads many commercial data formats. It's also easy to export a Tecplot data format actually from your in-house codes, for example. Using Tecplot has the advantage that it frees up your solver for simulation use. So if you have embedded post-processor, you can just do all the post-processing and visualization within Tecplot, and you can meanwhile post-process solve one of your cases. Sorry. It handles every kind of plot and animation, from very simple XY line plot up to complex 3D animations, and you can export publication quality plots. It is stable and easy to use, and you can customize and automate it. So I will bring that in. So this is a today beta version, so it just got released. And here is the new Tecplot version. So I will start to load a case that is made of many different data. So it's basically an elastic flat that has been computed both in a fluid structure interaction between within Fluent. So you've got two export files per time step. So as you can see, this is a transient case. And meanwhile, this mechanical simulation has been run on the flap itself. And we will see how we can load and compare those two data coming from different sources within Tecplot software. So I'll simply hit load data file here. And here are basically the data loaders that are coming by default within Tecplot. As you can see, you have numerous data formats that are supported, especially for CFD and numerical simulation. So I will start with the Fluent case here, and I will just specify my my files. So here I will just select all of my cases. It's really simple, and by clicking open, Tecplot will automatically recognize that here I have a transient case, and that transient case is to be loaded on the Dynasties here. So as you can see, by default, Tecplot basically displays a shading, and here I have a flow within that that cubic area here, and there is that elastic flap here that is in the middle. So I will just turn on edges, and as you can see, Tecplot discomposes the volumes on your results within zones. Here, for example, I have 9 zones per time step. And I will just turn on the edges to be defined from a geometrical point of view instead of having it delimited by the zones. So you've got a number of tabs here that allows you to change every aspect of visualization you wish to have and change that per zones. So we'll just select those zones here and define my edges as by creases. And here it is. Okay, in Tecplot 360X, you have a new graphic interface engine that is basically Qt, and that allows you to select and change the way you are visualizing numerous objects. So here, for example, I select a zone and I can turn on a meshing or a contour of vectors, shading, and so on. So I'll turn off shading here on my external walls so we can see the actual geometry. Here on the flap itself, I will just display a pressure contour just by, it's just one click away. So you can click and drag, even double click things to access the details, and you can change things really easily within Tecplot. So here is a very basic thing. Here I've got a solution time axis. So as you can see, I can hit that play button. It's DVD-like controls, and you can explore your result along your time axis. So I will now turn on the basic features for CFD visualization. So those are the 5% features that are used in 95% of the cases. Here I'm, for example, defining an isosurface of pressures that you can see appearing here. Same for the slices, so you can use that interactive slice positioning tool. And by hitting X, Y, or Z, you can just change the plane you wish to define your slice on. You've got more advanced detail in that, more advanced controls are in that detail button here. So you can define up to 8 slices or group of slices, and you can also define numerous slices at a time and so on. You can, for example, animate those slices, display vectors, contours, mesh, shade, and so on. So I will just bring back my primary slice here. And here it is. Regarding stream traces, once again, you can use that positioning tool that allows you to position stream traces really easily, clicking one by one, but you can also position them as a rake. Once again, by hitting details button here, you have more advanced commands, such as so either on surfaces of selected or active object by XYZ position or IJK indexes, and you've got different kind of stream traces. And then you've got a lot of options, such as, for example, markers here. That I will just decimate it a bit. Here it is. Oops, sorry. So you can basically have markers and that kind of things here. You can animate them and so on. Okay, and these are the really basic features for visualizing a CFD result. All right. Tecplot handles, as I said before, as many, well, it handles any kind of plotting and animation from 3D, that is currently what we are looking at, up to XY line plot. You can also extract data from your result, and that's what I'm going to do here. So we'll basically extract my slice over time steps. So Tecplot is currently looking through the time steps, it's done. And by doing so, basically, you extract a new zone that is appearing here, and that zone corresponds to your slice. What you can do, you can simply hit Control-C and Control-V to copy and paste a frame. So here, as you can see, I have 2 frames now. And that is a very easy way of working with multiple frames. You can even, if you don't need a big resolution, you can even paste it in a Microsoft Office application to easily create slices, for example, slides. All right, back to Tecplot. I will just switch here to a 2D view. And so here it is. I will just, so you can tile your frame, basically having them one over the other, which makes it easier for you to visualize and compare your results. So here it was a plane on a constant y, so I will just change here my axis x and y to get x versus z, and I can do that in plot assign xy. So we'll just choose x and z as my axis, and now I will just decide to display my slice only. So I will just right click here and hit show selected only. Here it is. So I don't want here a mesh, and that's it. So here I've got my slice in a 2D position, but as you can see, I can play the movie. My two frames here are not linked in time, so that's something you can achieve easily. Same in the contour level, so those two contours are probably different. What you can do, you can go in frame linking, and you can link those two frames in solution time and in contour levels. And if you do that, then you've got the same contour levels and you are looking at the same time step. So if you are exploring your result in time, then you've got an updated picture in your both frames. Another thing is that here X is increasing to the left, here it's increasing to the right. So you can simply double click that X here. And in range, you have that reverse axis direction. So you are seeing something more coherent between your two frames. Now regarding the XY capability, you've got different tools. For example, you've got the way of defining field variables such as a convective variable and state variable. And this is done here, so you can, for example, visualize vectors according to your velocity component. And you can also create XY line plots. So you can use, for example, that tool that is probing at a point within your domain, and it is creating a time series plot. So you have your field information versus time that is automatically plotted. So I will just click somewhere like on the slides, like up there. And here I have a new frame that is basically giving me pressure versus time, versus solution time. So we'll once again time my frame, so I've got a better overview of what I'm currently looking at. And here I've got my pressure over time. So in XY line plot, you are not working with zones, but with mappings. So here I'm on my time series zone, and I will, for example, display my my X velocity, for example. I will choose to have it on my second Y-axis, as velocity values are quite far from the pressure ones. And that's it. So here I've got my X velocity on the right and my pressure on the left. Once again, in the mapping style, you can access everything from the light layout, curves, symbols. So for example, if you decide to show symbols, but just on the X velocity, you may want to have a smaller square and fill it by, let's say, fill it in green. So here you have something like that. So once again, if you play your movie, you have all of your frames that are presenting the same time step, and here you have a little vertical slider that is giving you an indication on what is the current time step you are looking at. Qt allowed also to right-click line maps, and for example, you can access a Fourier transform within one click, so you have an information on the spectral or on the frequency response of your system. All right, I will just delete that frame here. Okay. Tecplot works with many frames, but you can also use it with many pages, and each pages can have many frames inside and many datasets, different datasets. So we'll just rename that pages Fluent, for example. So that was my Fluent case. And I will add a new pages here that I will call Fluent versus and this mechanical. And in that page, I will basically compare my Fluent result versus together with it, my and this mechanical. So if I switch to 3D Cartesian, I should have already my, so it was a copy of my last frame from the previous page. What I can do alternatively, I will just delete that one here and copy and paste that 3D view of my Fluent result here. Here it is. So now I've got one frame on my second page. And as you can see, I'm currently looking at my Fluent result. This is just a copy of the frame that was up there here. Okay, you can create a new frame and start from scratch. So here is something I will do just under here. And I will open now the NZIS results. So I will just take my NZIS data loader here, and I will just simply specify my NZIS result case. Here I've got the elastic flap itself, so this is a mechanical view of or computation of the elastic flap itself. Tecplot provides you a lot of tools to analyze, for example. So this is CFD analyzer, but we also have FEA post-processing tool, for example. And here I will simply derive a von Mises strain. And by hitting add to dataset, I just add it to my dataset here. In the contour, so you can choose to have up to 8 contour levels, and I will just choose my 50th variable here, which is the von Mises strain that I just computed. Once again, this is a transient case, so I can play it in time, and that's it. So now we wish to compare that and this mechanical result here with the fluid one over there. And to do so, there is an easy way. So first of all, you can just link your frames once again in solution time. So you are looking at the same solution time in both frames. And you can also link it in a 3D plot view. And if you do so, you are looking at the exact same point in both frames. That means that you are actually able, if you're interested in a little detail here, you are able to see the same thing in both. Here I will just reset I actually linked my frame in, sorry. I just linked my frame in the control details, control levels, and I don't want to do that. Okay, now you can overlay your frame so you will have one frame over the other. So here the first frame, it didn't disappear, it's just in the background of that one. And you can decide not to show the background of this frame here. So now I've got my NZIS mechanical result that is overlaid with the fluent one. I will just reset my contour for my von Mises stress. So we'll just so I've got something a bit more color. All right. And now as my two frames are, I will just kick that out. We don't need it twice. I will just be able to visualize my two results from two different solvers on the same frame. As you can see, there is a little offset here. It's just due to the fact that there is more computation step in the NZIS mechanical computations than in the fluent one. So when the NZIS flap basically moves 3 times the fluent one's moved once. Okay, so this is it for the very basics of Tecplot 360X, and those are really the basic features and use one can expect from it. We'll have a series of webinars, and we already have a series of video tutorials that allows you to explore it in a more deep way, let's say. Okay. So now I will speak about the second novelties of Tecplot 360X. So the first one was the Qt-based interface, the new GUI. And now I will speak about Tecplot's strategy to handle huge datasets. And basically that strategy is called load and demand, and it allows Tecplot software to just load the elements that you visualize without loading the whole volume. Means if you have a billion cells model and a 1 million element slice, you will just have 1 million elements approximately in memory. That allows you to load your dataset way faster, and also to save up a lot of hardware requirements, such as RAM, for example. So here is benchmark numbers from Tecplot Inc. So this is a 410 million unstructured case. And here we say standard Tecplot, that was basically the version 2013. We had approximately 700 seconds to load the ISO surface here on the wing, and peak memory was about 50 gigabytes of RAM. This is definitely something you currently find only on powerful workstation or even on cluster. With that new technology, they managed to cut it down to only 45 seconds of loading and 2.5 gigabytes of RAM. This is something that is definitely acceptable for a laptop, and that means that you could actually visualize that dataset on your laptop and even have 2 or 3 of them side by side for comparison. Same for the slice here. So with a standard Tecplot, we were at approximately 200 seconds and 20 gigabytes of RAM, and they cut it down to 2.5 seconds and 400 megabytes only. So I will just quickly show it to you. So I'll just launch my my Tecplot here, and the dataset I wish to show you here is It's basically a 5.7 gigabyte dataset, and it's the new data format that comes with that technology. It's called Subzone PLT. And so I will just load it right now, choosing my Tecplot data loader, Tecplot Subzone data loader here. And here is my case. So now Tecplot is loading it, and I will just, I will just bring in my task manager here. So I've got a 8 gigabyte of RAM laptop, which is definitely something that everyone can find at this work place. And here I'm looking for my Tecplot thread, and as you can see, it's about 580 megabyte of RAM, which is definitely acceptable. Here the case is loaded, and it's about the big case. It's more than 200 million elements. Here it is. So we've got 210 million elements approximately for that case. It's fast and it doesn't require much memory because Tecplot is simply loading the elements that are displayed here. Same if I want to display a slice. So at the very moment I click, Tecplot is loading into memory the elements that are cut by that slice. And as you can see here, the memory, the RAM usage is increasing as Tecplot is loading it from disk to RAM. And here it appears, so it's stabilized at approximately at 800 megabyte of RAM. So with 800 megabyte of RAM, you can visualize a slice on a 210 million point case, and that was just not possible before. All right. So that was it for a very short demonstration of the technology. It works. Basically, our customers that are implementing that within their workflow are really satisfied with that, with the speedups. Okay. So now I will speak about Tecplot Chorus that is aiming to visualize many results. It handles a problem that is encountered basically for people that have a lot of data file, and that data is most of the time spread over many files, directories, subdirectories, and it's hard to find, organize, and visualize all of that data. It's also time consuming, and it can lead to mistakes as you can basically think you are looking at something and you are actually looking at another case. This is of great use for design of experiment, parametric studies, experimental data, and Chorus handles up to tens of thousands of files at a time. It's a huge speed up for you and your workflow when you have those huge data files. And Tecplot Chorus is now coming with Tecplot 360X, which also allows you to post-process and manipulate a lot of files that are even big data visualization. Okay, I will just present you the data right now. So it's basically a parametric study here. So it's basically a study of 3 parameters that are MAC, incidence, and drift, so alpha and beta. And as you can see here, you have many points within your simulation domain, your design space, sorry. So each directory here is basically having a fluent result, that is fluent.case and fluent.dat here. So I will show you Chorus and those, I think it's about 32 results. So I'm just launching Chorus, which is basically my my latest version here, and it's working with 360X. I'm seeing some few questions that are popping up. I propose I'll answer them at the very end of the presentation. So here is a table view that basically summarizes all of your cases. And as you can see, so you can order your cases by any of your parameters. So here are my 3 parameters, MAC, alpha, and beta. And then you have a bunch of integrated values in that case. And those can be even, well, they can be given by your solver. So you can compute, for example, drag, lift, and slide forces within Fluent, but you can also compute it within Tecplot, for example, or within any other software actually, and bring that back within Chorus. You can filter your cases, so if you want to decrease the number of cases you are watching here, you can do that very easily. And each line in the table here it's basically linked to different things. It links to a set of images that are automatically created in batch, and a set of the data itself, basically. So we'll just look into my images here, and as you can see, I've got all of my cases here. So we'll just bring all of my images that I created previously, and you have no mistake possible as you can show labels. So here, for example, I just bring Mac alpha and beta. So every time I'm looking in a picture, I know exactly which picture I'm looking at and what is that case or this one. So you can compare a huge number of pictures one at one, and you can also you can basically compute a pixel difference within your images. So this is your reference, and you are looking at which cases are the closest and the furthest from you. This is very useful if you have XY line plots, so you can actually see the lines, how they behave regarding to your reference. Okay, I will just escape that view here, and I will present you the matrix view. Matrix view is basically a way to organize your pictures here. So you've got basically the Mac as columns here, and the lines are your different angle of attack. You can page that by beta. So here is my beta equals 0, 2, 5, 10, and 15. So that gives you also an overview on your design space. And you can once again select few cases, access either the images. Of course, you can switch those images here as well. And you can also access the data at every time. So we'll just select 3 cases here randomly. But let's say those 3 cases are interesting for you, and you wish to compare them to a deeper extent. You can just right-click View Data, and then you choose which data you have. So here I just have a fluent data. You can add a macro or a style template. Here I will just have a style. And by clicking OK, I'm basically launching those results within Tecplot 360EX for a deeper analysis. So here I've got my 3 cases, and that time it's not images anymore, it's the actual data. So I can perform any kind of operation I would be able to perform within 360EX. It is actually 360EX. So for example, I can just add, well, very simply a couple of contour here. And you have that chorus tab here that basically allows you to synchronize style so that contour adding will be effective on my 3 frames here. You can also compute difference data that basically gives you a data. So that time it's not a difference between pixel of images, but it's the actual difference, the quantified difference between your data sets. So this is actual data that you could save, and that is the difference between that one and that one and so on. So of course you can change your reference really easily. Here it is. And once again you can show, for example, alpha, beta, and Mac. And so you've got, once again at what case you are currently looking at. Okay. Every time you load something from Chorus within 360, it creates you a new page, which is telling you which cases you are using for. Okay. So back to Chorus, you have different views. You also have XY line plots, 2D scatter plots. So here I've got Mac versus drag, for example, and it's colored by alpha variable. You can color it by a new, there is a new feature that is basically the filter violation. So if you are using filters here, basically, so we'll just take the Mac, that's going to be very obvious. Here I'm excluding those values, and for example, I'm excluding few alpha values, and let's take one from the top. Okay, so you color basically to know whether you are satisfying all of your filters or if you're violating a dependent or independent filter, or if you are violating more than one of those. Okay, I just reset my filters here. Same, you have it in 3D view. So here I got Mac alpha versus the drag. And so here those points that are stacked up are basically the different beta I've been computing at. And you can define and set up response surfaces such as the one in gray here. Once again, at every time you can just select or click a point and access the corresponding images or load the data within Tecplot. All right. Okay, so that was it for Tecplot Chorus. Brief word about where to get support and more information about Tecplot. First of all, you can try it for free at tecplot.com/trial. For any question you may have, you can email us at support@tecplot.de, or if it's urgent, you can just call us that number here, and we can provide you easy support with online meetings, for example. We also propose new services such as webinar training and a Tecplot certification program. Brief word about the Tecplot certification program. So it's basically what I just showed to you. It's designed for, let's say, Tecplot beginners that want to have an overview of the software, and they can access the data, manipulate it, and a little quiz or a little test is proposed at the end of the certification, and people who pass will get a written certificate that can be added to record or CVs. You will find more information about this on tecplot.de. All right, thank you very much. If you have any questions regarding that, I will stay online a few minutes to answer questions that popped up. You can contact me for more information at the email address here, antoine.lager@geniascoregraphics.de, and we will put online a recording of the webinar and the presentation today. Thank you very much. So I have a question regarding the subzone PLT format that is basically that format here that allows speedups. Question is, what resources and most importantly, how much RAM do you need to create a subzone PLT format, and how to create it? Basically, can it be made starting from any file format? Nowadays, you have two ways of getting that subzone PLT format. Either you load the whole dataset within Tecplot, and you can do that in batch. So you load your dataset in Tecplot and you write it as a Tecplot subzone format. So I can just show you here within Tecplot 360. So you can just, let's say you have some data that is loaded. Just create a rectangle or a cube. Very well. Let's say this is your data and it's loaded within Tecplot. You can just write it as a Tecplot subzone data format, so using the Tecplot subzone data writer. And that can be done in batch. If it's of interest for you, I can show you how to do that. The other option is basically to export it directly. If you have an in-house code, you can use the Tech.io, which is a C++ or Fortran library. It exists in both languages, and that basically allows you to directly output a Tecplot data format from within your solver. If you are already doing so, just link to the newest Tech.io, and there is just one argument to change in a function that will basically tell your solver to export either on a legacy PLT or within the new subzone PLT. So you still have the option to export the legacy file format there. Question was raised by Peter. Does that answer your question? I will. Okay, great. Okay, that was the only question that popped up. If you have any, once again, you can just write me here at antoine.lager@geniascoregraphics, or raise it. I can stay online like a minute or. Okay, great. I don't see any other question coming up, so I will end up the session here. Don't hesitate to write me an email for any question you may have. Thank you very much. Have a good day. Bye.